Thank you very much. So I thought what I could do is, since there's immense expertise in this room on all aspects of COVID and COVID immunology and many famous authors here, I won't try and give some big teaching session on COVID immunology, as many people here know at least as well as I do. So what I'll do, that's my conflict of interest, I'll briefly summarize a few thoughts about the immunology, and then I'd quite like to talk, if I may, about this thing long COVID and what it is and what we think about it and where we're headed with it, because I do think it's a big and weird and unexpected problem. So, this slide is just to you can sum up this slide by saying, wow, what a crazy journey, what a steep learning curve we've all been on in the last 3.5 years. So things like, we know about coronavirus immunity and could write a textbook chapter on the importance of B-cell and T-cell responses, but how hard it's been to pin down the correlates of protection and work out what's doing what and what matters and where we're going to be headed. And, we've moved rapidly, haven't we, through those periods of we have no COVID-19 immunity, till we've got, 0 doses, 3 doses, boosted vaccine immunity, building up these complex patterns of heterogeneous hybrid immunity, in ways that we haven't had to decode before and haven't had to understand before and haven't had to rule book for before. So, what a lot of human immunology has been learned. So, what a huge amount of immunology has been learned, but also so many challenges to our prior assumptions. We've had to move on, haven't we, to each iteration, assessing the rules governing protection from variants in this long period we've been on of Omicron subvariants, frequent reinfections and breakthroughs. So, I can't do the rough on turf bit in the way that John Oxford does, but the only story I'll say about that is that I was the poor person who had to go on to Newsnight on the BBC the night that the Omicron sequence came out, and we were all feverishly sort of eyeballing the sequence, how it mapped onto the spike structure, and just being horrified at this nightmare of this thing that had come out that seemed to evade almost every possible neutralizing epitope. And so, late at night, I was going to the BBC building and going to the Newsnight studio. And when you go into that famous room where they've got the illuminated round table, outside sit all the kind of brainy researchers and producers and things, their laptops. And they stopped me just as I was opening the door to go in and said, by the way, what are you calling the new virus? I said, Omicron. And they said, no, we've been on to the BBC pronunciation department, and I think you'll find it's Omicron. So we require you to go through the internet calling it Omicron. I said, but I can't do that. Why can't you do that? I said, because they will laugh at me. It's like all the problems of being late at night in the BBC studio doing an interview on this thing. I sort of squirmed my way through the interview without having given a name to the virus, avoiding saying it together. So we've been through all this stuff, haven't we? That some people in this room on these papers, all of those unexpected twists and turns we've been through, the understanding that we were all building up hybrid immunity through our enormous infection and vaccination history, and then just when we thought we had these amazing vaccines that were going to keep us safe, and we had this enormous amount of protection headroom, the ink was barely dry on this issue of science that we'd written, when that headroom got massively eroded by, at this stage, the appearance of Delta. And then just when we thought Delta was a peak virus, Delta got sort of pushed out by Omicron, and Omicron by its subvariants. Yeah, we and others did lots and lots of work about this very complicated slide from one of our science papers, just reminding us that those mutations have complex implications for the immune response. We think of them in very kind of barn door terms of, has that change in the virus that escaped that neutralizing antibody response turned off a bit of immunity? But obviously, amino acid change in the spike sequence can do all kinds of things: turn off immunity, turn on new responses, turn on regulatory responses. The world of epitope recognition by T cells and antibodies is a complex world. But what I really wanted to do was say something that gets less attention about long COVID, and one of the other somewhat unexpected things that coronaviruses can do, although obviously we knew about it and should have been forewarned from SARS and MERS, and it's all contentious and it's all difficult in the current climate. How do you count it? Who has it? Does it matter which variant you got it from? What are the symptoms? What are the biomarkers and symptom clusters? What are the mechanisms? Is it doing a thing that we thought coronaviruses didn't do, and sitting in a persistent virus reservoir? What do we think about that? And if you put all of that stuff together, if, as I do, you end up inhabiting the world of all those patient groups and patient support groups and patient predator groups and things, they feel that there's a conspiracy theory, a conspiracy on the part of the establishment and politicians and medics to withhold treatments from them. And we all know what the treatments are, and we're not giving them for some reason. We've all done the work, and if you put a gun to my head and said, so what's going to the randomized controlled trial tomorrow, I wouldn't necessarily know. That's not a conspiracy, that's just not enough research, because you can't do 20 years research in 2 years. We need to know, don't we? Because unless we can have the right conversations with policymakers and politicians, we can't allocate healthcare provision for it, and we can't get people into the right referral pathways, and we can't get the right people into clinical trials. But we've known for a long time in the pandemic that it's a thing. There's ONS data, and this is from Paul Elliott and Helen Ward and the folks at Imperial in the REACT-2 study, and the trajectory of those curves in terms of percentage of respondents in the REACT-2 cohort of 72,000 people with persistent symptoms. Just tells you the story, doesn't it? That don't know people's COVID experiences in this room. On the whole, if you're one of the lucky ones, one of the sort of lucky 80 or 90%, you'll feel unwell with whatever symptoms for 4 weeks or less. Then you'll go back to your baseline health, and it tells you that there's that long, consistent tail of people for whom that isn't true, and a whole range of symptoms that just go on and on and on. In the cohort that we study, that's called the Wilco cohort, which is working out the immunology of long COVID, we've got loads of people who are 3 years plus now, really wrecked lives. So the argument about how to count it and who has it, how many have it, obviously does matter, because we have to try and engage people in the Department of Health and around the world and sort of try and get a fair deal for these people. Until fairly recently, the UK was in a strong position in terms of having ONS, Office for National Statistics, data on this, and we've changed over periods of time how we count it, but it gives you somewhere between 1.7 and 2 million people in this country, maybe 3% of the workforce out of action and down with COVID. Although in some of the kind of global, more macroscopic data sets, the number of the sort of true long haulers who are there long term is slightly waning, which I guess has to be good news, because the nature of long COVID is that where it's very obvious that it's very visible and very doable to count people coming into the curve. But if people start to say, well, actually, I can ride my bicycle again, I can get back to work again, and they go out of that disease curve, it's harder to count them coming out of it. But there are people recovering, which I guess is good news. And sometimes when I speak, even when I speak to some quite influential people quite close to government, there's a sense that this is some kind of sort of local middle class disease of sourdough bakers who've got too much time on their hands. It's so unspeakably not. This is a global disease that you have anywhere in the world if you've met this viral sequence. And that's this piece in the Lancet last week. I guess another sort of counter argument that it's not a disease only of sourdough bakers is that, like all aspects of COVID-19, it's a disease of severity linked to social deprivation. So your chances of having long COVID are roughly doubled if you're in the most deprived parts of society, for all the obvious reasons. That you'll have been less likely to work from home. You might be in a more exposed job. even if you have a lateral flow test and test positive, you might not be able to stay away from work. All the obvious points. And reflecting that, certainly in that very tough wave of kind of first wave, Wuhan wave long haulers that we've got, the professions that are overrepresented in long-COVID are all the professions you'd expect, the frontline workers who had no means of working from home or staying out of that exposure. And the last of these introductory epidemiology type points is that I think people I speak to sometimes imagine that it's a problem of the olden days and those horrific first days of the pandemic, and surely we don't need to worry about it anymore now that most of us are double, triple, or quadruple vaccinated, and there are so-called mild Omicron subvariants circulating. Sorry, Omicron subvariants circulating, and that couldn't be further from the truth. And this graph is a bit out of date now. So in the Omicron period, we've added more than 700,000 new cases of long COVID to the caseload. So we're not out of it, we'll see. Okay, so we've worked. We sit on lots of international panels and things with NICE and WHO, and have various different ways of counting it. You get different answers, whether you count a 4-week persistence, 12-week persistence, and many papers out there where I feel like this was quite an important one from Hannah Davis in one of the Lancet journals in clinical medicine, where she did an enormous international survey of sufferers and put together one of the first really comprehensive lists of symptoms that, from a standing start, told us this was a condition that was global, severe, and debilitating, and had maybe 200 symptoms on the list that were multi-system, multi-organ, varying with time, relapsing, remitting. So a complex picture. And that's from a paper that she wrote with the famous Eric Topol in Nature Reviews in Microbiology, just reminding us that that you've got these kind of core symptoms and effects that you're all familiar with now on things like neurocognitive effects and word finding and brain fog and wheeze and breathlessness and post-exertional malaise and all the things that we've all heard about very often. So they're all in there, and loads of other stuff besides. So we come to think of the term long COVID as an umbrella for this rather heterogeneous, multi-system, multi-organ relapsing and remitting. So I've got no prior assumptions that the first wave person who's perhaps an elderly male who was on ITU who now has persistent symptoms has the same molecular mechanisms going on as the kind of person who comes into our Wilco study, who might often be a woman in her 30s who got it during the Omicron wave, perhaps has breathlessness or whatever. There's a ton of stuff going on there and a ton of mechanisms implicated. So lots and lots of studies out there to find biomarkers. Now, I won't flag them all up or go into any detail, but they're all here for you to look at. So this one I quite like. She's a PhD student at Imperial called Felicity Liu, and she's been one of the people analysing that huge data set called FOST, which is a post-hospitalised COVID. So that was one of the first kind of tranches of NIHR funding that went into long COVID research, mainly led by Chris Breitling in Leicester, where the idea was to consent and recruit every person possible who was hospitalized during the first wave, that was the severe Wuhan wave, and just track them longitudinally with time and see what became of them, and just throw every technology you could at blood tests, serum tests, biomarkers, lung function tests, neurocognitive tests, and just try and paint the picture. And in that sense, I think it's been really, more or less kind of unique and valuable in the field. So in this example, they've thrown quite a lot of money at doing OLIC proteomics of all of the longitudinal serum samples from that FOST cohort, and this is a preprint of hers that's in revision, I think nearly out, where she does very well. Slide on it. Yeah, so she does very well in that top graph there. It's hard to see, but have a look at the paper, have a look at the detail at taking all of those different symptom sets and sort of stratifying the people into how many of them fall into particular subcategories of symptom sets. And then she takes different markers, biomarkers, in the OLIC data set and shows which ones are significantly associated with a particular symptom set. And it's in that abstract there on the last slide. She gets very, very big differences. So there are explicit serum biomarkers of long COVID symptoms, and there are different biomarker sets for different clusters of symptoms. And that to me felt important. And then people have seen loads of activity in the press last week on another paper from the same cohort that came out in Nature Medicine. And in a way, a much sort of simpler answer that people sort of seized on because it said something familiar. It said that when they looked simply at the kind of cruder serum biochemistry for the acute infection and looked at how that played out in the long term for persistent disease, there was raised fibrinogen that became a marker of subsequent cognitive deficits, and there was raised D dimer, which we talked about since the beginning of the pandemic, also as a marker of subsequent persistent disease. So people liked it because they felt like this was a proof that there was something going on the way that it was talked about in terms of microthrombi in this virus. So over the last year or so, we worked with Alexander Fleming at Nature Reviews in Immunology to try and put together everything that anybody's ever said about long COVID and to tell the whole story, which came out last month in Nature Reviews. And it's all in there. So have a look if you're interested in this stuff. And I suppose the way that I'd summarize 37,000 words of text is to say that at the beginning of all of this, we had a number of hypotheses on the table, didn't we? That it's a virus that binds ACE2 in many different organs and therefore could mediate direct cytotoxic damage of the type that you might see on an MRI or a PET, and that there might be persistent virus reservoirs, and there might be reactivation of endogenous herpes viruses, things like EBV, and there may be a sort of EBV glandular fever-like effect of disturbing immune subsets and dysregulating immunity, and there might be that kind of clotting thing going on in terms of vascular endothelial damage or activation. There might be mast cell activation, and there might be de novo autoimmunity, like we see in things like chikungunya virus infection, and there might be microbiota dysbiosis. So after many thousands of papers and a couple of years later, I'd say yes, there's evidence for all of those in the way that kind of CV hunting researchers do. We've all kind of got siloed into our little silos and are not doing very well at putting it all together and want to do better and get to the finishing line. That's my summary of 37,000 words. And for example, we and other people worked on defining the autoantibody profiles. There are many, many autoantibodies targeting many parts of the body that have been characterized. And one of the points that quite rightly is considered kind of low-hanging fruit and hasn't gone away is the idea that there might be a persistent reservoir of virus by driving the pathology. And that's obviously an important one, isn't it? Because a lot of the sufferers feel it to be true and hold on to it. And a lot of people in sort of biopharma like it and are pursuing it as hard as they can and trying to set things up as hard as they can. Because obviously, if you've got 400 million people around the world with this thing and whatever proportion of them have it because of persistent virus, and you've got lots of antivirals and monoclonals on the shelf and you could make them better, why not do it? It's hard, because if you simply track the immunology of, does it look like there's something driving some kind of rising immune response here? Slightly equivocal data, it's slightly hard to track. Some people will know the data on sort of proteomic analysis of S protein in serum. Again, it's quite hard to track. Very equivocal data on whether people do or don't see any improvement after vaccination. Very equivocal data, not pinned down at all, on whether the PCR virus in stool samples. And we'll talk a little bit about probably the best hope we've got, which is data from gut biopsy. This is a very complicated slide to see, but I'll talk you through it. It's a paper that we had come out last week, I think, in Nature Communication. And all it says is something very simple. If you're sort of pursuing this hypothesis, we worked an awful lot with people like Ash and other people here on the Bart's COVID sorted healthcare worker cohort. And one of the things we did in the first wave was to take every single healthcare worker who got infected, get them to keep a symptom diary, and take weekly serum samples and PBMC samples, and track the ones who got persistent symptoms compared to the ones that didn't, and then analyze all the immunology we possibly could to say, could we have told the difference between these people immunologically? Because out there in the world of long COVID, there are a lot of people who believe they have it because they made somehow an aberrant or inadequate immune response to their acute infection, matched by a load of other people who believe they made a sort of excessive or hyper-inflammatory immune response to their acute infection. And you didn't have to read my axes to see that if it's recovered on the left, no, it's not. It's recovered on the top row and persistent symptoms on the second row. You can't tell them apart. Yeah, they've all responded to the virus the same. They've all got durability of the immune response the same. There's nothing to choose between. So we set up this study where we recruit people and want to come give us blood samples in London, work at immunology long COVID, and we kind of throw the immunology book at them, try to do all the other things that most people here do, autoantibody arrays and multi-parameter flow and piece of immunology and transcriptomics, and that's all being kind of worked out and written up at the moment. I just wanted to say a few words at the end about this persistent coronavirus idea. So, to my mind, it comes out of this paper initially from the Nussenzweig lab. It was published in Nature, and if you don't know, have a look at it. Well, it's 2021, which is ancient by current standards, and it just says something really nice. It's really good science. They say that they looked at the B-cell receptor repertoire in people in New York, and they couldn't understand why, as the months went by, there was ongoing somatic hypermutation. So what was driving the somatic hypermutation? And because it was New York, they had ethics to take gut biopsies, and they looked in the gut biopsies, and in like half of them, they found the PCR virus in the gut biopsy, and that didn't say anything in particular like longcovid. It said it can persist in the gut. But then there was a related paper a little while later from this lab from Vienna, where obviously if you've got an IBD clinic, then everybody who comes to your clinic gets scoped moderately regularly, and many of them have COVID, many of them have long COVID, and there again they find that in half of all people they look at, they find it in gut epithelium, and they find it correlated with persistent symptoms. So, so I think to me that feels like in a difficult situation, the light under the lamppost where when there's something going on, we'll be looking there. And obviously armed with that, we've got lots of therapeutics we could go in with, although bearing in mind that they don't all have equal potency against all of the subvariants. But we urgently do need our biomarkers and diagnostics for recruitment to trials and trial endpoints. So that's really the end of my talk. So when I say that people are very upset with us about the lack of trials, if you go on clinicaltrials.gov, there are many trials out there, particularly in the US, and some of them may do well, but to me they speak to our kind of collective confusion, because there are things there to upregulate T cells and downregulate T cells, you name it, it's all in there. And what we need, if you remember the success of the recovery trial in the UK early in the pandemic for acute COVID, we need the recovery trial for long COVID. And despite many, many efforts, neither myself or anybody else has managed to get the powers to be around the table to get enough to momentum behind that. And I think I spoke briefly about our lab work, but that is the people who did it. And thank you.